Hello everyone, welcome to this video presentation. In this presentation, I'll be walking you through how do we represent sequences or input data in RNN, recurrent neural network. So sequences in RNN or sequential processing, they are non-independent. That means the sequences across the time step are related. So that's why we have special neural network called recurrent neural network. And how we represent the sequences, typically x1 bar and x2, x3, x4. So these are timestamp, each of the timestamp or time step, we have the input sequence. Now input sequence can be a number or can be an embedding for a token or a word. And across the time step, like x2, x3, x4, and xt minus 3, and up to time step t. That means these are the input tokens to the RNN. And for each of the input token, we have the corresponding output as well. So let me show you the meaning of that. So let's say the sequences at the x are stars illuminated the night sky with their radiant blah blah blah. So the output sequence would be just one step ahead. That means if you train the RNN with this pattern, if the current word is stars, then the output should be illuminated. And likewise, the illuminated is the present token, the output will be D, and so on and so forth. And as you notice here, the sequences of data, they are not independent. In fact, they are related to each other. So this is how we represent the sequences as in, or rather the input data that we use in RNN as sequences. And we call this as a network unfolding, which simply means time step. And each of the time step, you have the input data. Let's say this is a recurrent neural network and the present word and the output, which is y1, and then the memory, which is the hidden state for each of the RNN cells. So this box that you see is the RNN cell, and the activation, or rather the memory, is going to be computed in a sequential manner. And the next, cell will get the next word in the progression and the corresponding output. And likewise, you will see that all the words in a sentence can be processed in a sequence. And while the RNN is processing every word, it is also building the memory, which is a accumulated, or rather, um, you can say the consolidated weight of all the sequences in the preceding timeline. So this is called RNN unfolding, which simply means processing of the token in terms of a time step. Now, in this example that we are going to go through, how to maintain or compute the hidden state in RNN, we'll be using random embedding for each word input or each token input. For example, the sentence can be "I like the movie," and we can represent every token I like the movie, and each of the token can be represented by n-dimensional vector. In this example, we just simply use the random vector for each of the token. So that will help process, or the RNN will process the input. For example, I can be a 4-dimensional vector. It can be n-dimensional, but in this example, we're just taking 4 dimension just for illustration purposes. In the next video, I'll show you how RNN actually processes the input sequence to build the memory. See you in the next video.